Hi, I'm Lee Tushler with Design World magazine. I'm here with John Perzow from the Wireless Power Consortium. And John is going to talk to us a little bit about why you need an alliance of manufacturers making wireless charging gear. John, there's a variety of ways of charging things, and that introduces some problems. Why don't you talk to us a little bit about how you come into that situation and what you're trying to do about it.
Right. Great overhead question. Gets to the heart of the vision of wireless charging. So a bunch of companies came together, maybe 6 or 8 companies came together in 2007 with the same problem, which is we have different kinds of AC adapters. They're not compatible. We're filling the landfill with them. Some work better than others. Everybody has a different problem. The cell phone guys, the thing breaks, and it's the number one reason for failure. The carriers have a problem because phones die too early and they charge by usage, right? They don't want phones to die early. They want people to use them a lot. There are businesses that want to be able to attract customers to charge their phone because it's such a big need, but it's expensive if you have different non-standard, non-interoperable chargers. There's a lot of perspectives. So the industry, different parts of the industry came together with a similar vision, which is put your phone down on or near a charger. It charges, it's ubiquitous, it'll be available throughout your daily journey, and your phone will always be charged. And it's evolved to where not only that, but when you put your phone down, you've made a transaction. The charger knows that it's doing work. It knows there's somebody there getting a charge. And that's information that can tell a hotel that there's someone in the room, or a restaurant that there's somebody at the table, send a server, or a car that it's okay to offer services now because it won't kill the phone. So it's charging and the ability to get in touch with your environment in ways you otherwise couldn't.
Now, John, the auto industry is talking about wireless charging of cars. But that's not the same technique being used by cell phone makers, for example. Why is that, and is that going to be addressed?
Interesting question. So it's actually the same technique in a very high level sense. So it uses magnetic induction. It's like a transformer. Primary, secondary, separated though. The primary and secondary separated in distance. So it's the same general technique. But a car needs 2,000 to 20,000 watts, and therefore that when you go up in power, you go up in size. And so those are big things. And very few people will expect to charge their portable device on a car charger. So they don't have to interoperate. So while the basic physics is similar, they don't need to interoperate, and so they can go off on separate paths and work out the specifics of those technologies and perfect them for the actual use, but they don't have to work together. So we're not going there.
That's good. Energy efficiency is a big topic about wireless charging because it seems inherently inefficient. Could you address that?
Sure. So when you plug your phone into a AC adapter, from the wall to the battery, the efficiency is somewhere around 85%. When you add up all of the pieces, including the wire itself, you add up all the pieces, you get around 85%. That's about state of the art. It varies depending on the value of the wireless charging device and other things like that, what kind of a charging chip is in the phone, and there's quite a bit of variability, but that's about the state of the art. Right now, Qi wireless charging is also achieving about 85% if you exclude the part that goes in the wall, which could take it down another 10% or so. So it's very, very close and getting better all the time. It's actually quite close. The Qi system uses low operating frequency, and it uses what's called a close coupled system. And so the energy that's lost between the coils and the energy that's lost by the operating frequency is quite low. And so it's inherently a very high efficiency system. As you go up in distance, you go down in efficiency. Sometimes that's okay, for some limited use cases, but it's not the majority of the volume.
I see. here at the show you have a couple of examples of wirelessly charging tables, including one from a pretty well-known restaurant. Could you tell us a little bit about how those tables are oriented?
Sure. We have a bunch. Right behind us here is an IKEA table, as it turns out. Now this is designed for infrastructure applications, enterprise. Over on the other end of the booth we have, from England, straight from England, a charging table from McDonald's. So they've deployed quite broadly in England, and they use different techniques. This particular table is outfitted with transmitters that are underneath or embedded into the table, so the top is smooth. The McDonald's, after several years of market studies, have concluded that it's better to have the charging device actually through the table, because it's an automatic, intuitive to the user. You know where it is. It's waterproof. It's easily serviced. It's very robust. So there's different use cases, and there's different products that support those different use cases.
I see. You suspect we'll be seeing more like those in the future.
Wireless charging has gone, this year wireless charging has really accelerated. So it's quite common, it's tripled in volume. Consumer awareness has gone from 20 odd to 70 odd %. It's really changed. What we're seeing now in 2016, yes, we're seeing more power, we're seeing wireless fast charging, we're seeing greater Z distance, we're seeing greater ease of placement, we're seeing incremental improvements, but we're now seeing wireless charging moving beyond the cell phone. So we've seen it in our toothbrushes. It kind of started there for most people. Philips just a few days ago launched a shaver that's Qi enabled.
Interesting.
Yeah.
Well, that's cool technology, John. Thanks very much.